Welcome to this introductory video on Python regular expressions, or Regex for short. This video will cover the basics of pattern matching using the re module in Python. We will explore different regular expression patterns like \w+, AZ with a quantifier of 3, $start, and $. Let's start by understanding what exactly a regular expression is. Regular expressions, often shortened to Regex, are powerful tools for text pattern matching. They are used for searching, extracting, and manipulating text. In Python, regular expressions are available through the re module. Here's a simple example. First, we import the re module. Next, we define a text string. Python Regex is powerful. Then we define a basic pattern to search for, in this case the word Python. We use the re.search function to search for the pattern within the text. Finally, we check if a match was found and print a confirmation message if it was. Now let's explore some common functions available in the re module. The first one is re.search. This function searches for the first occurrence of a specified pattern within a string. For example, re.search our pattern, text. Next, we have re.match. This function checks if the pattern matches at the very beginning of the string. If the match is at any place other than the beginning of the string, it will return none. For example, re.match our pattern, text. Another important function is re.findAll. This function returns all non-overlapping matches of the pattern in the string as a list. For example, re.findAll our pattern, text. Finally, we have re.sub. This function replaces all occurrences of the pattern in the string with a specified replacement string. For example, re.sub our pattern, replacement, text. Let's discuss the basic syntax used in regular expression patterns. The dot matches any single character except a new line character. The caret matches the start of a string. The $$ matches the end of a string. The ** matches 0 or more repetitions of the preceding character or group. The ++ matches 1 or more repetitions. The question mark matches 0 or 1 repetition. Here is an example demonstrating basic pattern usage. First, we import the re module. Then we have a text string. Python is amazing and powerful. We can match any word starting with P using the pattern R, P\W+. The result of re.findAll on this pattern in the given text gives Python and powerful. Also, we can match words at the end of the string using the pattern R \W plus $. The result of re.search on this pattern in the given text will return powerful. Character classes are used to define a set of characters to match. Let's examine some predefined character classes. \D matches any digit, which means 0 through 9. \D matches any non-digit character. \W matches any word character. This includes lowercase a through z, uppercase a through z digits 0 through 9, and the underscore. \W matches any non-word character. \S matches any whitespace character, such as space, tab, or new line. \S matches any non-whitespace character. Matches any character within the brackets. Caret matches any character not within the brackets. Here is an example demonstrating character classes. First, we import the re module. Next, we have a text string. Contact john_doe123@email.com. Phone 555-123-4567. We can find all email addresses using the pattern R \W plus at \W plus \W plus. The result of re.findAll on this pattern in the given text gives john_doe123@email.com. We can extract phone numbers using the pattern R \D3 \E4. The result of re.search on this pattern in the given text will return 555, 123, 4567. Quantifiers specify how many instances of a character, group, or character class must be present in the input for a match to be found. Let's look at some common regex quantifiers. The ** matches 0 or more occurrences of the preceding element. The ++ matches 1 or more occurrences. The question mark matches 0 or 1 occurrence. N matches exactly n occurrences. Ln matches n or more occurrences. Nm matches between n and m occurrences. Here is an example demonstrating quantifiers. First, we import the re module. Next, we have a text string. The year 2023 had both good and bad moments. To match the letter, a repeated 2 or more times, we use the pattern RBA2, D. The result of re.findAll on this pattern in the given text gives bad. To match 4-digit years, we use the pattern R\B\D for \B. The result of re.findAll on this pattern in the given text gives 2023. Regex groups allow you to group parts of a pattern together. Let's discuss regex groups. Pattern captures and groups the matched pattern. Pattern creates a non-capturing group. Pattern 1 pattern 2 matches either pattern 1 or pattern 2. \1 \2 etc. are back references to the first, second, etc. Captured groups. Here is an example demonstrating groups. First, we import the re module. Next, we have a text string. John Smith's email is john.smith@example.com. To extract the name and email using groups, we use the pattern R\W plus \W plus. S email is \W plus at \W plus \W plus. Re.search results in name equal to John Smith and email equal to john.smith@example.com. Now, let's talk about the concept of greedy versus non-greedy matching in regular expressions. By default, quantifiers are greedy. This means they match as much text as possible, while still allowing the overall pattern to match. Examples of greedy quantifiers are the ***, the ++, the question mark, and m. Adding a question mark after a quantifier makes it non-greedy or lazy. This means it matches as little text as possible, while still allowing the overall pattern to match. Examples of non-greedy quantifiers are *+, and *ONM. Here is an example demonstrating greedy versus non-greedy matching. First, we import the re module. Next, we have an HTML string and lt_div_ngt, first content and lt/div_ngt, and lt_div_ngt, second content and lt/div_ngt. The greedy pattern R and lt_div_ngt wink with a frown at asterisk, and lt/div_ngt matches everything between the first opening and last closing div tags. The non-greedy pattern R and lt_div_ngt wink with a frown at asterisk, and lt/div_ngt matches each div separately. Regex flags modify how pattern matching is performed. Let's explore some common regex flags. Re.I enables case-insensitive matching. Re.M enables multi-line mode, where caret and $ match the start and end of each line, respectively. Re.S makes the dot match new line characters as well. Re.X enables verbose mode, allowing comments and whitespace in the pattern for better readability. Re.A enables ASCII-only matching for \W, \W, \B, \B, \D, \D, \S, and \S. Here is an example demonstrating regex flags. First, we import the re module. Next, we have a multi-line text string. The pattern R Python with the re.ignore case flag will match Python regardless of its capitalization. The pattern are Python, with the re.m, and REA flags will find all lines that start with the word Python, regardless of its capitalization. Let's dive into some practical examples of using regular expressions. First, we will start with validating email addresses. Here we have a function called is_valid_email that checks if an email address is valid using a regex pattern. The pattern are $\w plus at EZ0-9 plus /EZ0-9 plus $ ensures the email has a valid format. We test it with a few email examples. Next, we will work on extracting data from the text. Here we have a text containing product information. The pattern are product \w /s price $$ /d /d+, extracts the product name and price. The extracted information is then converted into a dictionary. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.